Hi, everyone. Welcome to Tech Talk, a podcast where Amit and I talk about various aspects of technology and its effect on socioeconomic and our cultural lives, etc. Today, we're going to talk about a very interesting topic. It's humanoid robots. Thank you, Amit, for coming up with this topic. We've talked about similar kind of topics, robotics, before, but as the technology progresses and new cutting edge companies are getting into robotics more and more and building more and more awesome robots, and they are very much human like. So we thought, why not talk about again about humanoid part of robotics? There are many ways robotics is advancing, but humanoid ones are quite interesting, and I think our audience would find it quite fascinating as well. So yeah, let's talk about humanoid robots.
So thanks, Rinat, again for that introduction. I was actually fascinated by this topic because Tesla released a video recently about its own bots or humanoid robots, and I it made me thinking like, okay, so Tesla is now investing in it, and we know there are certain other companies who have done a lot of good work in this area, especially Boston Dynamics. So these are the two companies who have developed. Honda has developed previously a SIMO robot, ASIMO. So these companies have developed robots that look similar to human beings, and that's why they are called humanoids. They are different from androids, so I'll just say that for now it's humanoids because they are robots. They are not humans, but they look like humans. Androids are part humans, part machines. So we are not there yet, and they look like human beings, but they are completely robotics inside. And an example of an android would be something from say Star Trek. Data is an android. The character Data in Star Trek series, The Next Generation. So humanoid are similar, but they just look like humans. They don't talk or they don't do anything, and they are robots. You if you look at them, you can see that okay, they are robots. They are not like they are bipedal, so they have bipedal locomotion in the sense that they have two legs just like human beings. There, so yeah, so they have two legs, they have two hands, they have a mouth to talk if they are talking, but they definitely have a head and with some cameras that look like eyes. I don't think they have ears, but might have sensors. It depends on what kind of humanoid you're trying to build. And they have a torso, and so yeah, so they are very similar to humans, and it's a very interesting piece of technology. And yeah, so that's why I wanted to talk about it.
Yeah, no, absolutely. And also, thanks for giving this insight of different types of robot. And I want to just dive a little bit deeper into it. So there are robots. They're like physical robots. I know we've talked about software robots before, but today we're talking about physical robots. So when we talk about physical robots, we actually immediately think about humanoid robots, big thanks to the media, to be honest. But there are many different types of robots. Robots that doesn't look like humans at all. They don't even have, a like a sort of like a torso at all. They just have. It could be a car or a vehicle or all of those things which are unmanned and moves around with an objective. You could call it a robot. I mean, to be honest, as the technology advances more and more, the definition of robot is becoming more and more vague because there are so many different types. So, among all of the different types, a very popular or a very identifiable type is the humanoid type, which is in early days, decades ago, it was, it looked like sort of tin can shaped, limbs. R2D2 and C3PO comes to mind.
Yes, from Star Wars, yes.
Yeah. And then, as the technology advances, we became, more and more advanced in sort of building more nuanced limbs and sort of motor functions of those limbs. So our robots became more and more like human. And the more I talk about it, I want to sort of mention this interesting topic called uncanny valley. I don't know if you know about this, Amit.
No, I
It's a
don't.
very interesting topic actually, and I think our audience will enjoy it as well. So the as humans, we whenever something look like us or something behaves like us, like humans, we find it, we find it more comfortable and comfortable to deal with it. As a result, obviously, because there is that benefit, humans kind of want to interact with other human-looking things. That's why, in robotics, humanoid robots have become popular because companies want to build things that will be, largely accepted. Now, beloved movie characters like that we really liked, and then more and more humanoid robots coming in picture in real life, and we started liking them. But as it becomes too much like humans, the sort of it we started to feel like a strange uncanny feeling, and that's when we stopped liking it because it's too much like humans but not quite there yet.
Not quite there.
So so just when we reached that stage where it very much looks like human, behaves like human, but there is just something missing, and that's at that stage we feel really uncomfortable and they have a strange feeling. And that, if you sort of put a chart like in an XY plot where robots are slowly becoming more and more human, and the more and more we are finding them likable, more and more likable. So the line is going up, 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 and then at one point we don't find them comforting or friendly anymore. We feel very uncanny and strange. And that's when it drops the level of comfort. And then when it becomes fully like human, then we feel comfortable again. So it sort of creates a valley in that XY chart, and that's what's called uncanny valley. Obviously, if it's fully like human, then we don't know that it's a robot. That's why we're more comfortable. But there is a sort of conspiracy theory that why did evolution make us this way? That something that is very much like humans but not humans, and we should feel sort of awkward or uncomfortable or strange about it. Maybe there was something that was very harmful to us in the past, but that's just a conspiracy theory, and I don't know any science backing regarding it, so I'm not in any way supporting that. But it is an interesting theory to think about, that as humanoid robots are becoming more and more like humans, there is a point where there is a drop in acceptance from humans.
Interesting. I think I've never heard this theory, but I think I've heard bits of it. Like yes, people find it more acceptable when the robots look like human beings, and it's incredible. Like human beings have evolved only on this planet with a specific gravity, a specific temperature, etc., and a pair of eyes, a huge brain, hands. We have 5 fingers. We have legs, and we can crawl. I mean, we can do so many things with our limbs, and I mean, evolution has played a huge part. And yes, if something looks like us, then we definitely accept it more compared to if something looks like a dog or a lion or something else. So yeah, so I think I can relate to that. But this is a very interesting theory, and I'll definitely want to read more about it. And thanks for sharing this because I think it's a interesting thing to definitely know about, especially when these robots are now going to be more and more part of our lives, and they already are. I mean, in some scenarios they already are, but I think let's take a step back and think about, okay, so we have robots that look like humans, and we know that, okay, it's good for people because people find it more acceptable. So let's try to create robots with that look like humans. So, and we've talked about the appearance as well. They just look like humans with a head, hands, legs, torso, everything. So that's that. But then what are the mechanics behind running a robot? So a robot normally is autonomous. So and some robots are remote controlled. So you used to have remote control robots, toy robots. My son is growing up, so some people gift him toys. I mean, he's too young for robots, but he still has a remote control car, a remote control excavator, etc. So, but I remember from my childhood that I was gifted a robot. You put some batteries and you just switch it on and it'll do some moves. So it'll do those moves autonomously. So it definitely has some chip that has a program in it, and that program will tell it what to do. More advanced robots will take inputs from the sensors and process them, and then give an output in the form of motion, in the form of some action, or some kind of voice response, or maybe a nod of head, etc. These are taking from the sensors, and these sensors could be anything. It could be for cameras to record what they're viewing. So then you can also have algorithms that recognize what the surroundings are through, say, machine vision. We've talked about machine vision, and then we've talked about AI. So how do we leverage that? Then there is this whole thing of balance. So if they are look like humans, they have to balance themselves. We find balancing very easy as we grow up. I'm seeing my son growing up, so he initially he found it very difficult, but then he got a hang of it. And say try to balance yourself on a skateboard. So that's again taking it to the next level. So yeah, so balance is another aspect, and then there are other things like, okay, how do we power the robot? Where is the battery pack? So then these are all the mechanics and the algorithms that have to be on a chip, and the hardware that's needed. And then how strong is it? What are the materials? How do we make it more flexible? How do we make the robot do all the range of human motions? Like our hands can move in as many directions as possible. Can the robot do that? How do we make sure the grip of our fingers can replicate can be replicated on the robot? Because we can lift an egg without breaking it. Can a robot do the same thing? And can then a robot pull a car with the same, maybe with a bigger force? So how do you make a robot understand all that? So there are different nuances to all these things, and I think that's where it becomes more and more interesting.
Yeah, yeah, absolutely. There's so many ways you can think about, there's so many aspects to think about when you're thinking about humanoid robot. But I keep coming back to the first, the core of how we landed on this humanoid design, because there could be robots which are built for a specific purpose, and there could be robots that are built for generic, like all generic general purpose robots, if you like. Now, for both cases, as if you are just thinking about an engineer with no sort of view of socioeconomic interaction, how the human ergonomics and how it will do all of these things, you would just come up with the best design for to perform a specific task if you're doing a special purpose robot. Or for even for generic things, you would have various designs, and that design of a robot may not look like humanoid at all. But how did we ended up how do we still have the humanoid sort of shape as one of the popular types? Because obviously, millions and millions years of evolution has sort of brought about these shapes which are kind of ruling the world, humans. So there obviously are various benefits for a general purpose robot to have the similar kind of shape and similar kind of ability, because it's obviously, when we talk about how did human became the top of the food chain, if you want to put it that way, um, it is because of our big brain. But on a humanoid robot, the processor is not going to be in the head like we have. However, when we were confronted with a predator, for example, a tiger, it's not, I think our brain had some sort of contribution on for us surviving. But I
Flight
think
mechanism, that's
our
called the flight mechanism, fear or flight.
yeah, yeah.
Some people
But
get afraid, some people start running. So the fear
yeah,
or
yeah.
flight
So that
mechanism.
decision making part might be done by the brain, but if your decision is to do flight, you should be able to take flight very quickly and survive. And a lot of us did, which is why we still exist. So we must not forget the sort of the nuanced design that we've sort of evolved into, and that is also a very sort of a strong design that have evolved and became, was perfected over millions of years of evolution. So as soon as we, try to find a solution to a problem, usually when we look at the nature, we find a good one. And in this case, looking at the nature is like looking in the mirror, and we found the best kind of general purpose robot and what shape it could be. Now, one could argue that the legs we have are not really good for moving fast. We could have had wheels with axles, although evolution wouldn't allow that, but that's a different topic altogether. But we might think that that would be a better design. But when it comes to terrain like surface where or stairs or sort of mountainous areas, over there, wheels or even the sort of the gripped wheels that they have in tanks wouldn't really work the way two legs work. So there are many general purpose benefits for humanoid robot, not just to be a friend to humans, which is also an important part, of course, but there are many benefits of this design anyway. And now, how do we make this design possible with all of these sort of constraints, mechanical constraints, electrical constraints, as you mentioned? How do we power it, etc.? That's obviously a completely a new era of problems, because the way we feel ourselves is completely different, because it's a chemical reaction, that how we generate energy. But it's a well, batteries are also doing chemical reaction, but it's a kind of a different way. But the first thing that comes to mind when we're talking about power, our battery, is that the way we do it is that we sort of continuously sort of consume fuel in order for us to keep
Food,
going. And we
consume
have a lot
food,
of,
consume food.
yes, that's what I mean by fuel for humans. And we have a lot of backups. I mean, even people can survive after, 5 days even, without food, not water, but that's a different, that's a different topic altogether. But if we looked at the problem that way, maybe then we could think about better solutions. I mean, obviously, using solar panels to continuously recharge may not be technologically advanced enough to work, because the amount of power generated is may not be enough. But yeah, it's interesting how these companies who are at the cutting edge of this now, like Boston Dynamics, and apparently with the new news, Tesla is also very much onto it, onto this area now as well. Is It's a very interesting space, and one to sort of watch out for.
Definitely, and I think you put it right, like why robots should look like us and what advantages it has. So I think we are not very fast, that's for sure. We are not very strong. Again, there are stronger animals in the world. We don't have a great vision. We don't have a great sense of smell, taste, etc. So we are very average when it comes to comparison. But as a package, I think we are very good because we have a enlarged brain compared to all of the species, and that has given us an ability to rule the world. But and given the hands, so I think if you don't have the opposing thumb, you it's very difficult for us to hold any tool. Without the opposing thumb, it's difficult to grab anything and then work with it. So our hands give us an advantage where we can use tools, stones, we can use wood, we can create fire, we can create wheels, we can create tools to cast iron, etc. So that gave us a very specific advantage over animals. That's why the animals never went beyond. So a lion cannot hold a screwdriver. A lion can't hold a drill machine like we can, so it loses out on that part. Maybe we can't run as fast, or maybe are not as strong as a lion, but we can hold a screwdriver and we can hold a drill, and we can do a lot of things with those kind of tools, and that gives us very specific advantages. And I think again, with when it comes to bipedal motion, so it's very rare for in the animal world to see bipedal movement. It's maybe only the monkeys, and monkeys also use a lot of their hands. Gorillas, chimpanzees, they use a lot of their hands, so they have very strong upper body, and they have good legs to hang themselves. But if you look at the majority of the animal world, they're all four limbs to walk around and move, and that gives them specific advantages. But I think when it comes to balancing, I think that gives us advantage, because then we can try to swim, we can try to stand on things, we can go up the stairs, we can balance ourselves on a rope, etc. So it gives us again very specific advantages. So yeah, so there are limitations, but there are advantages, and I think it's a good thing to think about, like why like us, because I think the problems that we are trying to solve are problems for us, and the reason we are trying to create these robots is to replace some of the manual work that we are doing. Say construction work, say drilling in the roads, it creates a lot of noise. I don't want to expose myself to that kind of noise, or even that kind of vibration when I'm holding the drill to drill a road. I don't want to do that. I don't want to go down the sewer. Maybe I'll send a robot, because it's a very dirty job. So I don't want to go up a high electric cable. It's quite high. I can fall. I can get electrocuted, etc. So, and then I don't want to go into a radioactive zone where I need to operate tools, but I can't go because of my because I can get cancer. I can have mutations in my body. So there is very specific scenarios for which we need humanoid robots. Even on the assembly line, we have to get rid of people on the assembly line and try to replace them with robots. So it's I'm not saying that it's bad for the people who are already working there, but those people can do some other constructive work, so we can use them for something else where they can be better utilized. So I think it's a win-win situation, and that's where the trend is going towards. And plus also companionship in the age of uh, social media and COVID. There is a specific advantages of being humans, and that's why I think most of the companies are now investing in robots that look like human beings, and especially Tesla now entering this market, and it gives us an advantage, especially on this planet. I mean, if you go on, say, Moon or Mars, you might need a different set of robots. So, like, you have rovers that can go across different terrains, because you still don't need a lot of tools. You still are exploring. So, for exploring, wheels are the fastest way to move, rather than having robots walking on stones and pebbles and trying to fall. So, wheels are much more stable. So, that's why. It's a different type of robot, and you mentioned that there are specific robots for specific things, but I think human robots have those advantages. And I think another thing is that if we get rid of the menial work and they are done by humanoid robots, then it gives us a lot of time to do other creative stuff, other innovative stuff. It's not to say that I mean, we are trying to get rid of people from their menial jobs, but it's just to make sure that the robots are doing those stuff which are very boring, repetitive, and not very good for your mind. And then people can take up other roles, other jobs, opportunities which are more based on their cognitive skills, and they can utilize their abilities much better.
Yeah, I mean, there is I know this could be a controversial kind of topic, but also it's not fully related to robots. But as you were mentioning, the jobs that we want to give humans more cognitive jobs. I was actually thinking, of course, yeah, that is always more fun and meaningful a lot of the times, but sometimes doing something repetitive is a little bit therapeutic. And I was doing ironing, and I was thinking that sometimes it's just you just want to do the similar movements without having to do a lot of cognitive thinking. but I guess we are making it so that the future world will not have much of those work for humans to do, which I don't know what kind of effect it will have, but it's an interesting thing to think about. And just uh, saying out loud, thinking out loud. But yeah, I mean, as humanoid robots become more and more advanced and can do all of these, like ironing or washing dishes and stuff like that, it takes away those tasks from humans to do. But sometimes humans do enjoy some of those things just to sort of zone out and do them.
So I think, yeah, I think that's a very good point. But then if you see, we have robo vacuums. It doesn't mean that we
Mhm.
can't do vacuum. We have Dyson, and it can do a great vacuum, but then it needs a human to operate it. So I think you
Mhm.
will still have those kind of opportunities if you want to do things by yourself. You will have certain things which are not smart enough for them for those tools to operate by themselves, which are just good enough. Because see, we have a dishwasher which is kind of a robot,
Mhm.
which can
Yes.
automatically wash dishes, but we still wash dishes with our hands. And there is still dishwashing liquid being sold in the supermarkets. So
Mhm.
dishwashing has not gone anywhere. I mean, people still do dishes by themselves,
Mhm.
even though they have dishwashers. Especially in a country like UK, where almost every house will have a dishwasher or a washing machine, people still wash their dishes or sometimes even wash their clothes. So yeah, there will be always opportunities for people to do such things if they so want. But I think the
Mhm.
whole idea is that if you have limited number of hours in a day, would you rather
Mhm.
spend them on ironing clothes, or would you rather go out and do something? Like you want to go
Mhm.
out to play
Yes.
tennis, you want to go out to explore on a hike or a walk. I think those are things that humans enjoy even more than maybe ironing, right?
Ah, yes, that is true. Actually, that's actually a good counter of what I said. Okay, so let's now talk about the AI part of robotics. So we are making the robots look more and more like humans. Now we are also at the same time separately, I guess, in research and technological advancement is happening. So non-humans can start to think or process information like humans. And once those two things are combined, that would be a leap into sort of humanoid robotics, because it would not only look and sort of behave like humans or close to humans, but also be able to solve generic problems like humans when given in any scenario, even without context. So that would be powerful, and that obviously comes with its certain challenges. The first thing that comes to mind is the processing power and where to house it. I mean, we house it in our brain on top of our necks. And one could argue that may not be the best design. And when there are certain structural differences between robots and humans, the way we store and process energy, and the way we sort of have sort of the healing ability, and the way we sort of have our motor functions, these are all structurally different. And for those differences, that could have an effect on the design. And that makes me think about the Boston Dynamics sort of prototypes of humanoid robots, which didn't have a head and had everything else. So it's another sort of super interesting thing to think about. How do you do the processing? Because yeah, we have made recently a lot of advancement in AI technology, but that requires a very specific type of chip only designed by NVIDIA, and apparently is well, not only the NVIDIA chips can do it, but they are sort of dedicatedly good at it. And those are quite expensive, power hungry, and space hungry, and heat generating. So all of these questions and constraints, how would the sort of the next years companies solve those problems? It's interesting space to sort of tune in every now and then.
Definitely, and I think you have raised a very interesting argument where, I mean, you need a lot of processing power, and you can't store that processing power on the robot itself. So they will need to connect to some kind of an internet or maybe some kind of network where they can connect and talk to a central server and just get a response. Because if you look at ChatGPT, ChatGPT is an AI tool, and it has scanned through thousands of websites, millions of websites, and then through machine learning it has gained some kind of insight, and now it can predict the next word that should come after a specific word. So say I say hi, normally the next word that comes after hi is how are you. So that's the next words, and that's what it predicts based on millions of text or sites it has browsed through. Now imagine you have all that ability, but it's still a very specific problem. It is going through websites, predicting what the next word is. It's not trying to, and it's doing only one thing. It's trying to generate words. It's not doing anything. It's generating words. It's not generating sound. There is a different AI tool for generating images. There is a different AI tool for generating videos, but they're all again software related. There is nothing hardware. They are still not able to hold a screwdriver. They're still not able to hold a drill. And you can say that okay, maybe it's not needed, but then it is needed because we live in a physical world. Are they able to drive a car? ChatGPT can't drive a car. So we again need a specific robot to solve that problem. So Tesla again with their cars, they are trying to go for autonomous driving, full self-driving. So that's again solving a very specific problem. Can they now go on a hike? So again a different problem. So I think the amount of problems that we have solved as human beings are immense, and they have still not been touched by robots. I think we are at a very initial stage of what robots can do. I think the world is now obsessed with software, but the software has to go somewhere and explore and do something. And for that, you need hardware. And that hardware also has to go through the environment, withstand heat, withstand cold, power itself, do the processing on board if you don't have an internet connection, etc., etc. So Starlink could be, I mean, if you think out loud, maybe Starlink is the internet backbone on which the Tesla robots will work and connect and talk to each other, and with the problem solving that they are trying to do by looking at their surroundings, I think that it'll build up, and then once one robot learns something, all the other robots have learned the same thing, so they don't have to train the robots again. So I think with that mechanism it can work out really well. But yeah, I'm blabbering
Yeah,
really
it's
at this
just
point.
a little bit of working out too well, to be honest. Because, yeah, so far in my head, I was thinking about, robots from different manufacturers, different companies doing different things. And they're all living in an ecosystem, like different types of people, from different countries or different preferences, living in harmony in a society, etc. But now that you've talked about a globally interconnected network of an army of robot, that just sort of brings a little bit of a sort of a concern, where if it does fall onto the wrong hands, and at the same time also if AI technology improves to a degree where it can sort of come up to its own objectives, then all of these could be a kind of a serious concern. And it just feels like that we will be in a science fiction movie. I don't want to mention which one, but one of them for sure.
No, I think we understand AI very little. I think whatever AI progress that we are seeing now is very software related, very unlikely it's hardware related. And hardware related there are very few companies because it requires far more investment, and there are far more variables to handle when you're just walking from, say, your door to the garden. So like you have to take a step, the terrain, the floor might change from a carpet to a wooden floor. You will have to open a door. You will have to look through a glass. You can maybe go through the glass because you can't differentiate between glass and the real object. So there's machine learning, some machine vision involved. There is a lot of variables that a robot has to handle before it can just go from the door to the garden. Now, whatever Boston Dynamics video that we have seen, I think if you look at the behind the scenes video, they first create a setup, and then They train the robot to go through that setup, and the robot learns by going through that setup again and again and again and again. And once it has mastered it, then it works autonomously. But that training part still requires the robot to go through that kind of thing again and again and again. And that's where I think that's where machine learning or other things might help. But this is a hardware challenge. And for a hardware challenge, you have to do it, you have to train it through hardware only. You cannot tell a robot to balance it a certain way. Maybe you can think about all the variables, but we don't do that in our head. It's all instinctive. Uh,
Yes, yes, absolutely. That general intelligence,
it's still
it
far away. It's still
fine
far
with,
away.
yes,
It's
that
still
is
far
far
away.
away,
I
and
mean,
how it
specific
behaves.
problems, yes, I think we are getting there, but general intelligence, very, very far away.
Very, very far away. And ChatGPT, by the way, I think we've talked about it in our earlier episode about ChatGPT. ChatGPT doesn't have general intelligence. It may appear as if it has it, but it doesn't at all. It's just sort of uh, telling you what the most likely response of a sentence or multiple sentences should be, but not an understanding of what it's doing. But eventually, when we do come closer and closer to general intelligence, as well as become more technologically advanced with humanoid robots, it would be very interesting to see how, when both of these things are combined, and as you rightly said, the carrying that processing power on board of the robot, the structure is actually quite unlikely scenario and unrealistic. So it would be connecting with the internet uh, to have like a sort of a bi-directional communication to send the problem and bring back the output what it should do. And it would be quite interesting to sort of interact with such creature, if you'd like, in
Yes.
future.
I
uh,
think Elon Musk recently said in one of his interviews with Wall Street Journal, maybe we'll share that video here, and it was a very fascinating interview. Maybe not Wall Street, maybe someone else. I can't remember right now. But in that video, he said that the Tesla AI or the AI being developed by Tesla is maybe 10 or 15 or maybe way ahead of OpenAI's ChatGPT or
ah,
any other AI tool because they have to
right.
deal with hardware variables. They are looking at environmental variables. They are not looking at software. Software you can do programmatically. That we have already automated a lot of stuff. But hardware is where the real challenge is, where you have to interact with something that you don't have any control. You don't have control about when an earthquake will happen. You don't have a control of when a
Mm,
tsunami will happen. You don't have a control
mm,
of what the temperature will be outside the next day. You can't predict when it will rain. And you can't predict what
yeah.
the terrain will be wherever you go, especially in an unexplored territory. So
Yeah,
that's
that is, those are challenges, but at the same time, we gotta still also think about that they will have a lot more senses and a lot more powerful
definitely.
senses than humans. I mean, we have five senses, including the tactile one, but they have so many different kind of sensors. Even the vision, we only see the visible light spectrum, but they will be able to see ultraviolet to infrared and much more, maybe the microwaves as well. So, their experience of surroundings would be vastly different than ours. Yes, as you said, they might not be able to predict earthquake, but they could potentially be alert at, 5 minutes before that, because they're going to be connected to the internet and the nearby Richter scale. So they will have a lot more advantage in terms of information gathering, and then how to process the information and make the right decision. That's a challenge that i'm
That's where
i'm
the
really
challenge is exactly
to.
because let me give you an example. So recently, we got installed a Harvey water softener, and the Harvey water softener softens the water in your house, especially the hard water, because it gives lime scale over all your accessories that use water. Now we also had a the drinking water tap, and that requires a separate filter because you should not be drinking soft water, and that filter has to be changed every 12 months. So I ordered the filter and I tried to install it by myself by looking at some YouTube videos. Unfortunately, the video that was there was not the same. So now I have a very specific hardware problem. I have to change the filter. Okay, and I changed the filter and the water started leaking. and I called the support staff, and they couldn't help me because of course they can't see what the issue is. Now, in a similar situation, what would a humanoid do? So it will have to try to understand what the problem is. So the problem is, I try to fit a filter, it starts leaking. Now I have to look at all the possible options. So I try to stop the tap, stop the water supply, try to see if I'm not fitting it correctly, try to look at the filter itself and figure out how to solve this problem. And the people in the support, in the call from the support, they said it would require about 2 to 3 weeks to get an engineer down there, and it would cost me 160 pounds plus VAT, etc., just for fixing a filter. And I thought to myself, that filter, it looks very easy. I'm doing something wrong, but I have to figure out what it is. Now imagine this is a very, very specific scenario. I have never been trained to do anything like that, and I'm now encountered with this scenario. How do I solve it? So the first thing I do is take a video of where I'm trying to fit the filter. So I took a video, then I try to figure out what the angle is, what direction I'm looking at, and is it the right thing. And then I try to see what's on top of the filter and where it has to go. So basically what happened is, when I removed the old filter, the two pipes that gets the water inside the filter, that moved. I just had to turn it and then fit the filter, and it worked. It's a very specific problem for which you can't train anyone, and now you
Yes.
encounter in the real world. Now imagine a robot has to do the same thing, a very specific thing. Like suppose there is an earthquake, it can detect an earthquake has come, but now you have to train the robot how to handle in those situations, and that situation the robot has never encountered. That's general intelligence. How do you
Hmm.
train some humanoid robot to handle a situation that it has never encountered? See,
Absolutely. And
you can train them on anything that you already know, but the unknown is where the intelligence comes.
absolutely, absolutely. One of the things I think I would pick up on this story, an aspect which you may not have thought about, is that the incentive that you tried again is because of the associated cost.
Yeah,
Now, when would a humanoid try something again after failing first time? If it has less than
true,
10% battery, would
true.
it try harder? If it has no internet connection, would it then keep trying for to re-establish connections so it can do the job, or would it move to another? So the incentives that are for us, it would be different. They will be incentivized differently. They might not care that they only have 5% battery,
Exactly.
because we may program them that you don't have to care if you die, just keep doing the job until you can. So that might be and over there, that's the scenario where I we might actually have a conflict with what a generally intelligent robot would want, because it may not want to
Do
carry
that thing.
on.
Yeah, exactly. And I think that's where people, I think they get excited, or also I think they misunderstand AI. I think AGI is very, very far ahead in the future because to
To
I
have
mean,
wants and needs and incentives like that, that's
plus doing
nowhere.
something out of the unknown, like if you don't know
Hmm.
about something, and so I think I read somewhere, or I heard some podcast or some place where they said, I will be worried when the AI can do something that it has not been trained on.
Hmm.
If you
Right.
have
Okay.
never given AI a text about religion and it still comes up with the concept of God, that's something worrying. But if you have exposed it to a text or some kind of thing,
Many
that
texts
many
that
text
are,
that talks
if
about
you
religion,
search
talks about
internet,
God,
then
then
yes.
then yes, then that's fine because you have trained it on that data. But if it has not encountered that data any time, how can it come up with that concept? I'm not talking about creating code. You can create a code by connecting the dots, but the concept itself of code,
Hmm.
if you never give it the
Yes.
concept of code, like you can actually create a program to do something, or you can have a concept of religion to and have God. If that whole concept is not there, then it's very difficult. Science comes from correlation. I mean, you correlate, you predict, you do experiments, and then you figure out things. Because I mean, how would Einstein have thought about space-time continuum or time travel or whatever he thought about? Like, it's very difficult to imagine if you have not been exposed to those things. But we have a specific way of doing experiments and figuring out things that we have never seen or heard. That that our senses don't trust, or we can't believe our senses that okay, quantum computing can actually exist. There is superposition that happens, and I mean there are so many things that our senses tell us, but it's all wrong, and it's all figuring out
Yes.
things, and that's a very difficult problem to solve.
Yes, absolutely. And I'm sort of anxiously and cautiously waiting for what happens next, and definitely tuning in and watching this space. And hopefully our audience will also be watching this space and tune in with us so we can share this journey together. This has been actually quite an interesting conversation, Amit. Thank you for that. And hopefully, the audience also enjoyed it very much. And we look forward to seeing you guys in our next episode.
Same
Thank you
here.
all for listening.
Thanks everyone. Thanks for tuning in, and yeah, had a good conversation. Thanks, Renat. Bye.